So this is the second lecture for section 1.2, and it ties up the topic of how do we display quantitative information or information from a quantitative variable um, in a form of a chart that could be useful for us for trying to find the underlying story to be able to understand what's going on with that distribution of that quantitative variable. So this section is about making histograms. In histograms, you've got, again, a data set which is made up of individuals. You have a quantitative variable that collects some information about those individuals. And then we're going to clump them together into things called classes. Classes are going to be um, ranges of values. They need to be of equal width. They count the frequency, how often, or the count. Those frequencies can be later changed into relative frequencies, percentages. And then we need to be able to put all those things together into a form that we can then do analysis about that random variable. Um, for an example, um, we're going to make a histogram out of this data. What percent of your home state's residents were born outside the United States? The country as a whole has a 12.5 foreign-born residents, but that varies from 1.2% in West Virginia to 27.2% in California. The table below presents data for all 50 states. Remember, this is a data set. So what are the individuals for this? The individuals are the individual states, and the variable, the data that we're collecting from those individuals, again, is what percent of the state's residents are foreign born. Now, when we see this data can be overwhelming, but what we'd like to do is organize it by, again, putting each state into a particular class, and then we're going to count up how many states end up in each class. Again, because they're ranging from 1.2% to 27.2%, one way to break up this data is to go in classes of width 5, starting at 0. So 0% to 5%, 5% to 10%, etc. There's only one problem with this, and that is what do you do with something that's exactly 5%? Which class does it belong to? So what we say is we're going to say that we include the number at the low end, but we don't include it on the upper end. So something that was exactly 5% would end up in this group, not in the previous group, because 5 belongs here, but it's excluded there. All right. Now for the process of taking all this data and putting it into classes, there is a spot on the next page to capture this data, but because I didn't plan well, these pages don't end up facing each other. So I'm going to keep track of the data here. Go to a slightly thinner pen. Is that the thinner pen? Nope, this is the thinner pen. All right. And I'm going to, again, collect data in each of these groups, including numbers on the low end, excluding numbers on the high end. So we start with Alabama, which is 2.8%, and that belongs in this group here. And then Alaska with 7, Arizona with 15, Arkansas with 3.8, so it's in that group. California with 27.2, there we go. Colorado with 10.3. Connecticut, 12.9, Delaware, 8, Florida, 18, Georgia, 9, Hawaii, 16, and there's 5% there. 13 goes here, 4 goes here, 3, 6, 2.7, 2.9, 3.2, 12.2, 14, 5, 6, 1, 3, 1, 5.6, 19, 5, 20, 10, 21, 6, 2, 3, 4, 9, 5, 12, 4, 2, 3, 15, going there, 8, 3, 10, 12, 1.2, 4.4, and 2.7. So it looks like I've got 20 in this group. I've got 13 in this group. It's like I have 9 and 5, 2, and 1. And if we add up those numbers, 3 plus 9 is 12, 17, 19, 20. Carry the 2, 2, 4, 5. Yep, it ends up totaling up to 50. So there's our breakdown on how many states end up in each group. One more time, 20, 13, 9, 5, 2, and 1 for a total of 15. Okay, so we are going to now make histogram bars that are going to be equal in width. So that first bar is going to run from 0 to 5. And in this axis for keeping track of the count, the number of states. Oh, that's pretty bad. There we go. And there's our bar that's 20. Now, for histograms, these bars do touch because they represent a continuum of data. Um, they Let's see if I can get them all in. This one's 2, and this one's 1. There we go. And there's our histogram. All right. Um, we got the labels on there. That's a good histogram. Now, what do we do with this histogram? Well, we use our socks again. We're going to discuss the distribution by looking at the shape, outliers, center, and spread. Shape, and this is where I'm going to make sure I include my context, that the distribution of foreign-born residents is, in this case, right skew. That tail is on the right-hand side. This is a right skew distribution. S for shape, O for outliers. And I don't see any outliers. There doesn't appear to be any outliers. Now we're going to talk about more about how to nail down this outlier question in the next section. Just hold off on that. We talk about the center. Now probably the easiest way to talk about the center is talk about the middle number. The middle number, which we'll get again more details in the next section, which would be the 25th state. Now, the 25th state, the first 20 are in that first group. The next 13 on this group, I say the 25th state has to be in this range. So the middle number um, is between 5% and 10%. Okay. And again, more information in the next section as we try to nail down this idea of middle number, or which we're going to rename as the median. And the last one is what about the spread? The range, which is a measurement of spread, is 27.2. That was the highest state, minus 1.2. That was the lowest state, giving us a spread of 26%. All right, and there's our histogram, and there's us making doing a summary of that distribution, um, very much based on that histogram. All right, so to summarize the idea of histograms, remember histograms um, summarize quantitative data. Bar charts summarize um, categorical data. Um, Notice, remember, bar charts have gaps in them. Histograms don't. Don't use counts as in your histogram. Um, the difference between this is a confusing statement. Counts are not data. Okay. It's like, remember, data is the information that we're getting from the individuals in the data set. Counts are summaries of data. So remember that how many states were in a particular range is not considered data. It's considered the summary of data. Um, Whenever we can, we should use percents. So it's a little bit easier to read. And it ends up that the graphs themselves end up being exactly the same. I could have easily put a bar over here, right here where it says two states. Well, that's 4%. Right here where it says four states. Well, that's 8%. And right here where it says six states, well, that's 12%. So the graphs could look exactly the same, but we could use percentages there. And it's probably a little bit easier to read when that happens. Um, and if just because it looks nice doesn't mean it's a meaningful display of data. Um, so to summarize what we had in 1.2, we have a bunch of different graphical ways of summarizing data, um, quantitative data, and those were dot plots, stem plots, and histograms. Remember, we look at these graphs in order to get an idea about the overall pattern of the data, any departures from that pattern. Whenever you're asked to summarize or to describe a distribution, don't forget your SOX, shape, center spread, outliers. Um, Remember, the shape could be symmetric or skewed. Um, and whenever comparing, make sure that you discuss those socks. Oh, and use comparison words. All right. And that pretty much finishes up section 1.2.